Okay, welcome to Moving to Databricks. Before I dive into the topic, let me first give you some context about my company and what we actually need Spark for. So wetter.com is one of the biggest German weather portals and mobile apps regarding weather forecasting, as the name tells. We also do a lot of media productions with weather content for many of the major German TV stations. And last year, we decided to build a third business for building analytical data products we want to sell to our B2B customers. Let me give you two examples for this. The first are so-called weather indices, where we combine weather data with sales data for different product categories. There we calculate from the past, we train our models to learn the weather impact on the product category, and then combine this with our weather forecast. So we can tell you what's the weather impact on your product group, like ice cream, or even other product group like electronic goods. And this information our customers can use to improve their programmatic ads, for instance. A second example I would like to give you is related to geodata. We have a lot of location data from our mobile apps. You see a front end we did with one of our partners, GfK. Here you see the visits in German bigger cities centers for this year, and you can see the clear drop in spring when the COVID-19 started, and much less people went to the city centers. And this you can use for detailed analysis on retail locations or other industries like tourism. Yeah, my name is Carsten, and at wetter.com, I'm responsible for the IT side of all our data products. And so I have to make sure that all this works. And yeah, there we use a lot of Spark, as you might guess. But before we look into our journey to Databricks, let's have a brief look how our world looked before we use Databricks. So this is a typical architecture picture from a 10,000 feet view. You might already have seen a couple of times. We get data, streaming data through our APIs. We get batch data deliveries through S3. For data processing, we used Spark on EMR, Elastic MapReduce, an AWS service. Our data was stored in S3 buckets using Parquet format. For reporting, we use Tableau with Athena. That's a serverless SQL service offered by AWS to do internal reportings. To our customers, we don't have a real front end. We have REST APIs where they can download the data, or we deliver the data using S3 or other means of transportation. Yeah, this worked pretty well. So why did we consider moving to Databricks? Well, the first and main motivation was the data tables Databricks is offering. So we had the requirements to do GDPR deletes of single records. And this was quite painful if you have big data sets on S3, but also for other data corrections, as if we did something wrong in our pipelines or had to do some minor enhancements, we always had to do a full recalculation of all our derived data, which took a lot of time and also involved quite some downtime. And then, of course, the platform itself. So we were looking for a notebook environment that improved our usability and productivity. We will look into this in details. And also with EMR found out that 80% of our EMR costs were from dedicated development or analytical cluster and not from automated jobs, because everyone was using a cluster of its own, which was idle most of the day when someone was just trying to figure something out. So that's something we hope to improve as well. And finally, MLflow was interesting for us because in our existing projects, we had some hiccups regarding the handover between data scientists and the data engineers when it comes to improving the models. We started to build a custom solution. In this talk, I will not go into detail, look into this here, because we don't have that much experience with MLflow yet. So yeah, let's migrate to Databricks and Delta. Let's first look at the infrastructure side. This was the architecture picture I just showed you 2 minutes ago. And for migrating to Delta and Databricks, what do we do? Instead of storing Parquet files on S3, we use data tables. Instead of EMR, we use Databricks clusters, of course. And like tada, some PowerPoint magic, and the migration is done. Of course, this happened in an instance, so there was some work involved. You have to take some decisions on the way, and for the rest of the presentation, I would like to share you the experience we made during this journey. So the first thing you have to consider when you start using Databricks is you need a Databricks workspace. And there you have different options. You can use a single classic workspace. That means one workspace for all your stages and projects. We have our projects and stages separated on AWS. And yeah, we also need this to go in Databricks. You can do this logically in the workspace or physically by having different workspaces. The downside here is these classic workspaces, they must be manually created by Databricks. So no automation here on your side. Then, of course, you can have multiple of these workspaces, but they all have to be set up and configured manually. And if you don't have a single sign-on solution, you can integrate with Databricks. This also means user management per workspace. Then there came a new feature, the so-called Account API, just quite recently released by Databricks. There you can create these workspaces on your own using this new API. This wasn't available when we moved to Databricks, so we decided to go for a single workspace, and we haven't met any limitations yet. We have all our data in one AWS account anyway. So the single workspace was the best solution for us. If you need multiple workspaces, I think it makes sense to have a deeper look into the Account API. To set up the workspace, Databricks requires something from you, or requires something from us. So first in a S3 bucket where all this Databricks workspace data is stored, like the notebooks and other stuff. Databricks needs an AWS IMA role to be able to deploy from their account into our account. And of course, you need some instance roles for the EC2 instances that make the cluster similar to the EMR instance roles. And then it creates, during this workspace creation, something in your account. It creates a VPC and all the related AWS resources. The downside here is you cannot reuse an existing VPC. So we had to redo our VPC peerings. You can provide a specific IP range for this VPC, but this is something you have to do manually before Databricks creates a workspace for you. With this new API, I've heard it's also possible to deploy into existing VPCs, which might have simplified things for us, but it wasn't too much workaround anyway. Looking into security and combining Databricks and AWS, where now each user has 2 logins, as we have no single sign-on, one for AWS, one for Databricks. On the Databricks side, each user must have a valid mail address. This also holds true for the technical users we use. A little bit of hiccup, but nothing big. For all these users, you can create tokens. That's these tokens you use to access the API for running automated jobs. Of course, you can restrict access to the different clusters based on users or groups you've defined in your Databricks workspace. And what is really nice and what you can see on the screenshot, you register the EC2 instance roles in Databricks that are available, and you can restrict access to these instance roles as well, which has the benefit, even if the users are allowed to spin up their own and configure their own clusters, they are only allowed to use the instance roles of their project. So they cannot take another instance role to look into some other project's data. This is something we use and works really well. There also is the possibility of configuring IAM pass-through. So that means instances of your cluster don't run with a specific role, but they use IAM role of the AWS user you used to log in. We cannot use this as we don't have single sign-on for AWS, which is a prerequisite here. But I think it makes sense to be able to share clusters even among projects, something we are not, we cannot do for now. When it comes to cluster configuration, everything was really straightforward. We reused the init scripts we had from EMR, so that's mainly pip installs. We even could drop a few packages that were available. Some difference here is for the worker instance, you have to decide for one EC2 instance type. So you cannot use instance fleets as with EMR and have the cluster picks sort of the instance types depending on the size. But you can mix on-demand and spot instances. What we usually use for our daily clusters is we have one on-demand instance for the driver, and then followed by spot instances. And the auto-scaling works quite nice. So for our development clusters, we usually have like 2 workers and a maximum 12 or 20 workers, depending on the workload we're doing. And if the resources, nobody uses the resources, the cluster scales down automatically and then scales up if more than one query or larger queries or jobs are executed on the cluster. So this really helps us reducing the development cost, which were the major portion of our cloud costs. Yeah, so much for the infrastructure. Let's have a look on our Spark pipelines, how we migrated our data and applications. So the most simple thing was to convert the Parquet files we already had to data tables. It's just this convert command. It requires some compute resources for analyzing the data, but we haven't experienced any issues here. But with Delta, there come in a few new features and SQL commands. The first is optimize. What does it do? Optimize takes a lot of small files and combines them into larger ones. So in our jobs, we didn't write small files. We had this quite well configured in the past with EMR. But if you do some update or delete on the table, we really generated tons, like thousands of small files. And this is something you have to mitigate using Optimize. You can do this periodically as a housekeeping job, or you can figure this as a table property. So that is done as part of the DML, but it's something you really should do. There's a Z-order feature, which improves selective queries. This cannot be configured as a table property because it's more expensive. We already had something similar, well, not that well implemented, but more roughly implemented using partitioning and sorting within partitions. We just kept it, and Z ordering on these tables really didn't change anything. So it's something we're not using yet. The last command is really important. This is vacuum, because if you start doing deletes on your data tables, this will generate new Parquet files in S3, and the old files will stay on S3, which is great for this data time travel feature you have. But after the retention period, so after a certain period, these files are not needed anymore, and they will just fill up your S3 bucket. So here you need some periodical housekeeping. Let's have a look where to store the metadata of our tables. And first have a look at the table metadata itself, because with Delta now, for every table we had in the past, we now have 2 tables. First, the data table, which is called native data table, which we got by converting our existing Parquet data or creating new tables. But unfortunately, these tables cannot be accessed by Athena. And as we used Athena for Tableau, as we don't have a cluster that is running all the time, we want to continue with Athena. we have to create these, I don't know if there's an official name for it, I call them symlink tables. So it's another external table that allows Athena or other tools using JDBC to access the data tables. And there, of course, you don't have all these features like time travel and DML, you just can read the data, but for reporting, that's fine. Then the next question is where to store the data. We had all our Hive metadata, so information about our tables and the AWS Glue data catalog. With the Databricks Metastore, you have a second option. We continued with the Glue data catalog because it's a place that can be accessed from tools like Athena. And it's also a place you can access from different Databricks workspaces. We might have this in the future. The only downside here, it's not officially supported with Databricks Connect. What this is comes later, but let me tell you, for us it works. We haven't any big issues here or any issues at all, so we stick with the Glue data catalog for our metadata. Surprisingly, the biggest effort we had was regarding our workflows. We used AWS Step Functions, which is a serverless workflow engine. On the side, you can see like typical workflow for us. We have a lot of single steps running sequentially. First, the cluster is created, then all the steps are executed. Each step in this big picture called the second step function that starts the jobs and wait until it's complete. We use Lambda for adding steps to the workflow. Access control is implemented by IAM, and yeah, we had a nice overview. Introducing Databricks, this changed a little bit. So the same workflow you see here on this slide, and it's not just a tiny workflow. And this is not because the complexity is still there, but it's hidden. Why is it so? With Databricks, you have two types of clusters. You have the all-purpose clusters and you have job clusters. Job clusters are much cheaper regarding of Databricks units. So it makes sense for periodical jobs to use these job clusters. The downside is you just can submit one Spark job, which gets executed. And when the job finished, the cluster is terminating. So we could use this with this detailed workflow, but with the downside that for every step, a new cluster would be we would have to create a new cluster. This, of course, would really delay the workflow overall. For the production workload, maybe that's still okay, but for testing a workflow, then all the spinning up the clusters is more time than running the complete workflow on a test data set. So we did some refactoring here and used, created our own workflow in Python to launch all the steps in a sequence with the disadvantage that we don't have this graphical overflow anymore. And I think this applies to any workflow tool you use because this is something that's not specific for step functions, but for these job clusters. And finally, let's have a look what we had to do with our applications. Well, we had in our pipeline still some steps where we didn't do the processing with Spark, but with Athena. We started with that last year, but Athena cannot write to Delta. So we migrated these steps to Spark. It's not a big effort putting a SQL step into a Spark program, but it had to be done. The next thing we had to change is we usually process the data day by day. So in order to handle late coming data, we deleted the last 2-3 days and just recalculated the complete data. We did this by really deleting the objects on S3. This is something you must not do with data tables because then the data table will lose the reference to the files. But here's where the delete commands come into play. And if you run delete on a complete partition, it just returns immediately. Yeah? So it works even faster than the S3 deletes. For writing data, you might either use the insert command, or if you use the write method of the data frame, you just swap the Pake format by data format, and there you are. And the nice thing if you do this is there's no explicit adding of partitions afterwards. This is handled by the data tables themselves. Okay, that's now we have migrated the applications. Let's have a look on how analyzing data in our data lake and developing and working with the Databricks platform has changed for us. First nice thing we observed here that the Python packages we install on the cluster are available on the notebooks as well. The notebook runs on some cluster node, I think on the driver. So you really have the same binaries. In the past with ME clusters, we had some issues with visualization packages like Folium. We couldn't include it because the binaries were on the cluster, but not in the Docker container where the notebook was running. This now works seamlessly for us. Regarding accessibility, the nice thing is immediately after you've logged into the Databricks workspace, you can access your notebooks even without a running cluster. So if you just want to look on some code, so the last results that are stored within notebooks, or just want to learn something while the cluster is still spinning up, the notebooks are already accessible. Also, attaching the notebook to another cluster is just a click. There's no need of restarting any components as we had with the EMR notebooks. Usability improved. That was also one of our goals. So now the code completion works really nice in the Databricks notebooks. And at least myself, I use a lot of SQL commands directly if I just want to do some analytics, look into the data, and using the Databricks notebook, you can do a quick visualization, plot some graph or some bar charts to give you a little bit more meaningful insight. And also the table representation is much better and the data is much more readable than with these EMR notebooks. The last point, this Databricks Connect I already mentioned. If you don't like or don't want to work with notebooks, then Databricks Connect is definitely the tool for you. Because if you install it, it allows you to submit a Spark job locally on your laptop with the files, with the programs you just change locally on your laptop and submit it to already running all-purpose cluster in the cloud. So you can use the same environment you will use for your production workload. You directly see the driver output on your console. That really work great, but one thing you have to be aware of, if you have different time zone, like myself, located in Germany, our AWS account is in Ireland, so there's a difference in the time zones, and that gave me some funny side effects and took me some time to work this out. Then, of course, very important, how does collaboration work and how does Databricks integrate with Git and Bitbucket? We use Bitbucket. So you have some built-in collaboration. It's like this Office 365 editing. You can have two persons editing the same notebook at the same time. You see that another user is working on your notebook. You see the cell he or she is just working in. That's really nice and funny feature, but more important, of course, is Git integration. There's a direct Git integration built into the UI of Databricks. So if you have a notebook, you can sync it to a repository and some branch, but you have to link every file manually. Of course, we had already a lot of notebooks from our time developing with EMR. We couldn't download, you couldn't do a bunch or bulk download and have this already linked together. So, but luckily there's another way, and that's the approach we ended up using. There, if you install the Databricks CLI, something you want to do this anyway, I guess, there is commands for workspace, export and import. So I check out all the code from Bitbucket on my local laptop, then do a Databricks workspace import. Then I have the latest versions in my Databricks workspace. I can work with them, modify them. Once I'm ready to push this back into Git, I do the export to my local machine and then do git add commit push. And this also works well if you change more than one files. And we tried both ways, but everyone in our team ended up with the second way. Okay, let's have a brief summary of what we've seen today. So first point, I haven't really mentioned performance because performance wasn't a driver for us. But of course, before we migrated, we did a 2 weeks POC with Databricks that really helped us a lot. And of course, we looked into performance here. And we examined 2 dedicated steps of our workflow, and we roughly observed the factor 2 here. We kept the Spark version the same, so we are still on Spark 2.4.5, not on Spark 3 yet, using the same instance from AWS. It's the same cluster size. Without any other changes, we got a factor of 2. In total, this is hard to compare for us because our pipeline and the functionality in it increases, so we really cannot compare to previous months. Anyway, it wasn't that much important for us. More important, of course, is the topic costs. This is really difficult, not that straightforward to compare, because the cost for Databricks and EC2 are higher than for EMR and EC2. But we save resources by sharing these autoscale clusters. And we did some scenario-based calculations here prior to that. And so, okay, also with all these other productivity improvements, these DML capabilities, the business case is really positive for us. And this, of course, was important to convince my management that we can use Databricks. The migration effort, as you've seen in this presentation, was mainly for changing the workflows. What really helped us here is we had automated integration tests in place. So after all the migration steps, we just reran our integration test and checked everything is working. And there was hardly any work for the notebooks. We just import them and they're converted to Databricks notebooks, and there you go. Yeah, that's all. If you have any questions, I will be available in the chat for some more time. If you have some questions later or would like to learn about our data analytical products, you can contact me. Here are my contact details. And finally, of course, I'd ask you to don't forget to rate and review the sessions. Then enjoy the rest of the Data and AI Summit.